This is your math teacher speaking, and we are going to graph sine functions. Okie dokie. So remember, we want our theta or our x or our t, whatever variable is here, we want it to have a coefficient of 1. So we're going to graph this y equals 2 sine of theta over 2 plus pi over 6 minus 1. So your first things first is you have to get your variable to have a coefficient of 1. So the coefficient right now of theta over 2 is going to be 1/2. Okay, think about it as x over 2. You would say your coefficient is 1/2. So we need to bring that 1/2 out. So we have y equals 2 sine of 1/2. Now when you take 1/2 out of theta half, you have theta left. Remember, theta is just some unknown, okay? It's just like x, it's just like y, it's just some unknown. So now you're going to have to do a lot of fractions because what the coefficient of pi over 6 is just technically 1 over 6, right? So if you take 1/2 out of 1/6, you're technically dividing. So 1/6 divided by 1/2 becomes 1 over 6 times 2 over 1. So you can cross simplify. This would become a 3. This would become a 1, right? Because the GCF between 6 and 2 is 3. So multiply fractions, you just multiply straight across. So you have 1 over 3. Okay? So this now becomes theta pi over 3 minus 1. And remember, I said the easiest thing to do would be to wait and graph your vertical transformation at the end. So let's just go ahead and focus on this part of the function, okay? So your A is going to be 2, so that's how high your sine wave is and how, like this. So that's going to be your max and then your min. Your B is 1/2. Your C, it's going to be the opposite. So remember, if we're going positive pi over 3, if that's what it says in your problem, you're actually going to the left pi over 3. So I'm going to notate that with a negative. So it reminds me that, hey, you're going to the left, okay? And then your D is -1. But remember, we're going to do that at the very, very end, all right? So then let's go do all of our characteristics of this sine wave. So we have our amplitude we already discovered was 2. So that means that my max is going to be 2 and my minimum is going to be -2. My period, okay, our formula is 2 pi over b. So 2 pi over 1/2. So remember, let's go do some scratch work again. We have 2 divided by 1/2. So remember, when you multiply and divide fractions, or sorry, when you divide fractions, you do keep, change, flip. So 2 over 1 times 2 over 1, which now becomes 4. So your period is actually 4 pi. So this is the length of your cycle, okay? So if you think back to a parent function of a sine wave, you usually start on the x-axis at 0. So this means that your cycle length is going to be 4 pi units. You're going to start at 0 and end at 4 pi. But remember, you do have a horizontal shift of -pi over 3, okay? So we're going to do that right now. That's our phase shift. You're going to take whatever is equal in your parentheses and equal it to what would have been your start point and what would have been your finished point, okay? So we're going to take theta plus pi over 3 and equal it to 0. Then we're going to take theta plus pi over 3 equal to 4 pi. That would have been our endpoint. Think about it this way. If I had this pencil laying here and I said move it over 1 to the right, you would just pick this up and move it 1 to the right, right? So that's exactly what we're talking about here. Where this would have been 0 to 4 pi, would have been where our sine wave is, but I'm asking you to move it to the left, pi over 3, so we're just going to take this up and move it. But notice the distance didn't change, okay? The distance is still 4 pi. So then, let's solve for theta. 0 equals -pi over 3. Then we're going to subtract pi over 3, right, to solve for theta. Theta equals more side work, okay? What is 4 minus pi over 3, or 1/3, okay? So remember, when you multiply or when you add and subtract fractions, you have to have a common denominator. So we're going to put that over 1. So what's the common denominator between 1 and 3? Well, 3. So multiply by 3 over 3 on both sides. So now we get 12 minus 1, both over 3. So we get 11 pi over 3. So what this means is our new start is going to be at negative pi over 3, and our new end is going to be 11 pi over 3. This distance is still 4 pi. Okay, that did not change, just like this distance is 4 pi. We didn't do anything except for here's our function, and we're moving it. Still the same length. Now let's go find our critical points. So this is going to help you get a super accurate graph, okay? Because we're going to have a max, a min, and on your x's, but at what points? So that's what we're going to go find. So you're going to take your period, which is 4 pi, and you're going to divide it by 4. So this means we're going to have a critical point or a number on our x at every pi units. So let's go do our x scale. This is just going to give us all of our x values. So remember, our starting point is at negative pi over 3. So that's where I'm going to start, negative pi over 3. But how would I move to the left or to the right? Okay, well, our critical point says that your next x value is going to be pi units away from here. Okay, so let's go ahead and give pi a denominator of 3 to make this easier on ourselves. So if I had a coefficient of 1 right here, right, because that's technically what that is, how would I get this to have a denominator of 3? You would have to multiply by 3 because this is technically 1 over 1. So what you do to the bottom, if I multiply by 3, I have to do to the top. So you get 3 pi over 3. So that's what we're going to be adding each time to make it easier on ourselves. And remember that 3 pi over 3 is still pi. Same exact thing, I'm just making it easier. Okay, so what is negative pi, which is technically negative 1, plus 3? Well, that's going to give us 2 pi over 3. Now add another 3 pi over 3. We're going to get 5 pi over 3. Add another, we're going to get 8 pi over 3. And we should end at 11 pi over 3. Okay? So what this does is this takes the length of our cycle and divides it equally into 4 parts. Okay? And let's go ahead and do a balanced graph, which means you have one cycle to the left and one cycle to the right of your starting point. So now if I'm going to go the other way, I have negative pi over 3. I'm going to subtract 3 pi over 3. So I'm at negative 1 minus 3, which is negative 4 pi over 3. Subtract 3 again, negative 7 pi over 3. Subtract 3 again, negative 11 pi over 3. And I should have 4 points, so I got to go one more. Negative 13 pi over 3. Okay, so this is going to be everything on my graph. All my x's. Okay, remember you do have, from our beginning, we do have an amplitude of 2. So that means our height is going to be 2 units up, and then our minimum is going to be 2 units down. So when you draw your graph, give yourself some room because we also are going to have a vertical shift. Okay, so here's 0, right? Now let's go label all of our x's. Here's 2 pi over 3 and 5 pi over 3, 8 pi over 3, 11 pi over 3. And now that's the end of our first cycle. I could ask you to go one more cycle, but for this example, we'll just do a balanced graph. So one positive cycle on the right and then one negative cycle to the left. So negative pi over 3 is here. Remember, that was your starting point. So maybe put like a star or something so you know that this is where you start. You don't start at 0. You start at negative pi over 3. Then we have negative 4 pi over 3, negative 7 pi over 3, negative 11 pi over 3, and negative 13 pi over 3. Okay, so these are all our points where we're going to have something happen. Then let's go 1, 2, let's just go to 3, okay, negative 1, negative 2, negative 3. And it would be good for you to have a handy dandy highlighter or a different color or something. Because what I want to do is let's graph this sine wave without a vertical transformation first. So we have a positive sine wave. What that means is there's no negative in front of here. If there was a negative here, we would have to go opposite of what a parent function tells us. But because we have a positive one, we're fine. So think back to a parent function. Sine waves start on the x-axis. And where's our starting point? It's at negative pi over 3. We're going to start on the x. And then think back. Did a parent sine function, did it go up to the max or did it go down to the min? It went up to the max. Now your next point's not 0. Your next point in your scale is 2 pi over 3. So now you're going to go up to 2. Then the sine wave continues down to the x, down to the negative 2, and back up to the x. Okay? So there's one side, one positive side. Now let's go to the other side. So we're going to go negative 2, then up, up, and down. Okay? So this is going to be a sine wave without our negative 1 vertical transformation. And this is why I would have a different color, because now we have to shift this entire graph down 1 unit. So that means every point that you have needs to go down 1. So if I'm at 2, I'm down at 1. If I'm at 0 and I subtract 1, well, now I'm at negative 1. If I'm at negative 2 and I subtract 1, now I'm at negative 3. So here is actually the correct wave. So think about it like this. The one in the pencil is y equals 2 sine 1/2 theta plus pi over 3. And the one in my pink highlighter is the one we actually wanted. The y equals 2 sine of 1/2 theta plus pi over 3 minus 1. Okay? And then remember to check yourselves. Use something like Desmos. Okay? Go graph it. See what it becomes. So also, I forgot to say this before I did the video, ended the video, but make good choices and do your quiz. Okay, bye.